Tutorial 1. A river barge whose cross-section is approximately rectangular carries a load of grain. The barge is 9 meters wide and 30 meters long. When unloaded its draft depth of submersion is 3 meters, and with the load of grain the draft is 4 meters. Determine the unload weight of the barge and the weight of the grain. So in this situation, it is talking about the barge here. So the barge here is it looks like a ship, so but actually it is like a box that brings sand and something towed by a boat here. So a tugboat, for example, will pull the barge, okay, from one point to another point. So barge is a rectangular boat, okay, used to loading and unloading things. So and then, for example, if we draw the cross-sectional area here, for example, this is the barge. So when unloaded, the submersion is 3 meters. So when unloaded without any load here, so the depth is 3 meters. However, when it's loaded with a certain amount, so the submerged depth here is increased from 3 meters to 4 meters. So for unloaded weight of the barge, so for example, for the barge without any weight here, so the submerged depth is 3 meters. So and then we know that there is a force of buoyancy acts here, and the weight acts downward like this one. So and then we could write the equilibrium, so which is the weight of the barge, which equal to mg, is equal to force of buoyancy, which is can be calculated by using the equation of rho g and volume. So we substitute the rho and g here, 9,810, and this is the volume of the submerged area, because the depth here is only 3, so we need to calculate the volume of the displaced water. So the displaced water is only at this area. So we get it is equal to 7.946 kilonewton. So this is the weight of the barge, because the weight of the barge being equilibrium with the force of buoyancy. And then when we put extra weight, so for example, we have a barge here, so and then we put a weight here under the in the barge, so we found that the submerged area is increased from 3 to 4 meters. So and then we could write an equilibrium in forces as this one. So means that the force of buoyancy that works upward like this is equal to the gravity of the weight, gravity of the barge, and also plus the weight of the load here. So we could write as this one, and then we would like to calculate what is the weight of the grain inside the barge here. So it is equal to force of buoyancy minus with the weight of the barge. And now the force of buoyancy here can be calculated by this one, and please make sure that you use the depth of 4 meter, because in this situation the submerged depth here is 4 meter, not 3 meter anymore. So and then we minus with the weight of the barge, which is calculated previously here. So and then we could get the weight of the grain is 2.648 kilonewton.